So this is Thinking with Math Models, additional practice for Investigation 2, problem number 10. And it has 4 parts, and so we're going to work through these parts together. And it says write an equation and sketch a graph for the line that meets the given conditions. And use one set of axes for all 3 graphs. So we're going to do 3 graphs, and then we're going to compare them. And the first one says a line with a slope of 3 and y-intercept of 5. So they've given us what we need to know. There's the slope and there's the y-intercept. So if I just go to my graph paper and it says a slope of 3 and a y-intercept of 5. So y-intercept is 5 and the slope is 3, which means it goes up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And it could go opposite direction, back 1 and then down 3 this way. And so then I have my line that meets the criteria given for that problem, a slope of 3. It continues in either direction. Slope is 3 and the y-intercept is 5. So there's my y-intercept. 0, 5 is my y-intercept. And my slope up 3 over 1. So slope is up 3 over 1, which we just say is 3. So that's question A for that one. And then it says a parallel line, a line parallel to the line drawn in part A with a y-intercept greater than 5. So we want a line that's parallel to this one and the y-intercept greater than 5. So there's a whole bunch of lines that would be true for. So we could pick anything as long as the y-intercept is greater than 5, any place along here. So I'm actually going to go way up here to the 13. So there's my y-intercept is much higher, and I want it to be parallel. And for it to be parallel means that it would have the exact same slope as this one. So really I can just work this way, 1, 2, 3, 1, backwards, 1, 1, 2, 3, down. And so if you notice, when I make it with the same slope, slope of 3, I just change the y-intercept, and now I have a set of parallel lines because they have the same slope. So I could go right here, 1, 2, 3, 1, same slope. Now I have 2 lines, and they are parallel. So now, the third question should be real simple because a line parallel to the line drawn in parts A and B, this time with a y-intercept of less than 5. And so if I go, I'm going to actually just make it go through 0, make my life simple. Y-intercept is less than 5. And again, to be parallel would mean that I would have the same slope, 1, 2, 3, 1, 1, 2, 3, 1. If you notice, I could actually work backwards, 1, 1, 2, 3. All I'm doing is, again, making that slope of 3 each time. And again, now I have a third line, and you notice it has a slope of 3, up 3 over 1, and it is parallel to the original 2 lines. And the equation for the line that each of these lines, if I actually write the equation for each of these lines, this one is y equals 3x plus 13. Put that down so you can see it. And this one is y equals 3x plus 5, y-intercept of 5. And this one is y equals 3x, and that's it, because it's plus 0. And so you might notice that the only difference in these 3 equations is really the y-intercept. I'm actually going to put the plus 0 in there just so you can see that that's the y-intercept at 0, 0. Don't really need to write that because it's not adding anything. But the key to this is if you want to have lines that are parallel, then they have to have the same slope. So you notice that in all 3 equations, it's 3 times x. They're all going up by the same amount each time. And that's what you get with parallel lines. And I think that actually answers question, or part D. What do you notice about the equations and the graphs of the three lines? Well, obviously the three lines are parallel, and the equations all have the same slope. They're all multiplied by 3 for the x. They all go up 3 and then over 1. So that's how you find parallel lines with equations. Same slope.